thing. Means when you provide them certain amount of temperature, they become very soft. That is the reason it can be molded into very different shapes, then cool down to become hard again. Means when we provide certain amount of heat to that particular polymer, they become very soft in nature. That is the reason they can form the different kind of shape. Means when we molded them, they take the shape of that particular mold cavity, and when they cool, they again become hard. So this is a very good way of transition or the phase transition from one phase to the another phase. Again, they come back to this another phase. And you know, thermoplastic have this nature. If you want hit them, again you cool down, then you again get the same kind of features or the polymer. It is therefore the nature of again you molded them and you then you cold them again and you got your material. That is the reason this polystyrene can be recycled. Means we can use them twice, or that depend upon the quality of the polystyrene also. Okay. So for that reason, this polystyrene can be recycled. Okay. And generally, the polystyrene, see, this is your like how this polystyrene is manufactured. So definitely here there is a double bond present over here. Means it have to be follow the free radical vinyl polymerization. So in this vinyl polymerization, free radical, you know, they are going to form a chain kind of process. So that is the reason they are very linear. Means they will form a straight line over here. They are form a very linear. And that is the reason, as I told you in the previous lecture also, we are studying about vinyl, then we have to come across the isotacticity. So, this vinyl, whatever you got the final product vinyl, you got like isotactic, pseudotactic, and atactic form of polystyrene. So, this isotactic polystyrene have different property and different application. Pseudotactic also have different application as like your atactic also. So it is consist of a linear molecules. It have a very linear chain and they are quite chemically inert. Okay. Acid, alkyls, oxidizing or reducing agent have very less effect on it. Means suppose a few of the acid, many acid polystyrene can resist or alkyl like NaOH, Na2CO3, the basic part or the oxidizing or the reducing agent have very less effect on it. Basically, the commercial grade of that we generally the commercial grade of polystyrene is have a atactic in nature. If you look into this, polystyrene is this, but here like atactic. Atactic means there is a very random orientation, and for this random orientation, they have a glass transition temperature is around to be like 85 to 90, the transition is there. Okay. But pseudotactic, you can see you have a melting temperature means the crystallinity, the as they are very wellly arranged in their structure, pseudotactic and atactic, they are quite well arranged in their structure. That is the reason they are semi-crystalline in nature. Okay? And if they have a semi-crystalline in nature, then you can see like your melting point can be little bit increased. So whatever the commercial product that we get over here, The commercial product of polystyrene, they are generally composed of your atactic. Okay. And if they are atactic, means they are having a amorphous in nature. Okay. That is the reason you can see like polystyrene are quite transparent in nature, as only atactic can give you a quite transparent in nature, as because they have a amorphous in nature. Okay, is that clear to everyone? Okay. So close packing means, if I talk about the seniotactic and isotactic, they are due to this well-arranged structure of this benzene ring. Okay, they are very close packing into this. Okay, that is the reason the flexibility means they are very difficult in flexibility and they are quite rigid in nature, as they have a very strong intermolecular forces, and that is the reason they are quite strong. Means if you compare with your atactic, seniotactic and isotactic, this seniotactic and atactic polystyrene is quite strong than your atactic polymer. Okay. That is the reason isotactic polystyrene is said to be highly crystalline in nature, as this symbiotic polystyrene is like isotactic, it is also highly crystalline, and atactic is not crystalline and they are wholly amorphous in nature. Is there any doubt up to this? Okay. Though commercial, we know that the polystyrene we in market that is available, or the commercially they are using that, they have a tactic in nature. So that is made from your free radical or bulk or suspension polymerization. These two process generally in the industry they use to manufacture your polystyrene. Okay, and that is your initiator and your reaction will be produced. But what happened while we do this bulk polymerization, there is a chances that it will take a exothermic reaction. Exothermic reaction means when this reaction will start, there can be some energy evolved. Okay, means energy will come out from that reaction, and it can be blast in the industry also sometime. So to control the exothermic reaction of this polystyrene polymerization, there is we generally in industry they follow two-stage polymerization process. Okay, so in the first stage, the inhibitor-free styrene means we didn't include anything to the styrene. Generally, the styrene, the monomer, is first subjected or it just added into that tank, okay, and they first do the reaction. Okay, so half of the reaction will be carried out with the help of your few of the catalysts. Then it is followed by highly conversion, and there is a process. Okay, then the temperature is increased to certain state, then your whole reaction will be take place. Okay, and if you see in the pictorial form, okay, there are different type of polystyrene you can get in the market, and this is known as your expanded bead polystyrene. This is known as your molded foam. This molded foam is generally used for your ice, okay, ice packaging and this. And if you saw that, you can just carry the medicals like blood samples or something by keeping some ice pack. So it give a very good insulation property and the ice will not melt over here. And this is your epox resin form. Okay, expanded polystyrene. This is known as your expanded beads, and this is known as your expanded polystyrene. Okay, so we will study in the next few one to few slides what are the different types of polystyrene we get. Okay, the pure
Under
molten
polystyrene, it's a ABS or ASA, right?
uh, ABS. Yeah, that is we do the copolymerization to the polystyrene.
Okay. Through for polystyrene, copolymerization of polystyrene gives ABS, you mean to say?
Yeah, that is we do with the acrylobutyl butadiene. Okay, so that is a different form. This is I'm talking about your pure styrene.
Okay,
Okay,
okay, okay.
no, not mixing of anything. This is
Oh, got
I'm
it.
just talk.
Basically, from pure styrene, we are driving ABS, ASA, all are in the same category only.
Yeah, they are we do a lot of copolymerization to get that different kind of polystyrene. Okay,
Okay.
according to, and why we do that also that we will study in the next slide only.
Yeah, because
Okay,
in automotive exterior, generally we are using ABS, so that's what I asked. Okay.
okay, yeah, acrylobutadiene styrene, right? Am I correct in this
Yeah,
way?
right, right, right.
So that why we do that, why we are using that acrylic butadiene over there, that is a reason. In the coming slide only you have that. Then I will discuss about that.
Sure, sure.
Okay.
Thank you.
Yeah. So the pure molten polymer that emerge from the reactor go to the spinner or an extruder to the provide the desired finished product. Okay. And you know polystyrene can be molded.
Ma'am,
As for that,
ma'am,
yeah,
that step to step three is there. Always that step three will be the final product for polyester, or it will be the beads also.
beads also that depend upon the what kind of mold you have applied in the lux in the extruder.
Okay, but that powder form is it's only polyester, polypropylene, or it is also a polyester. Step one is also polyester. Only step two is polyester.
Yeah, this is like if you got that expanded polystyrene, this expanded polystyrene is a specific type of polystyrene. Okay, the beads is there, then you can go for the expanded bead in the step three. You can form this kind of molded form. Okay, this is the yeah.
EPS is the polyester resin.
Yeah, this is known as expanded polystyrene. The name is that. Okay,
Okay.
EPS. Oh, in the next slide, I have here I will give you. Okay, it is usually in the general purpose. This GPPC is very different. Okay, let me just take out this. Yeah. So this general purpose or the crystal, this is the name of we have a very different type of polystyrene. According to the industry, what people they do, they co-polymerize this polystyrene or according to their requirement, they modify the polystyrene. So different industry have different name. Okay, so this GPPS grade, okay, or this GPPS, the name suggested the general purpose polystyrene, or suppose HIPS means high impact polystyrene, and we have expanded grade that is known as EPS, expanded polystyrene. Okay, so on that basis, like suppose if you are making this polystyrene as a flame retardant, okay, means the fire will not catch, okay, in this polystyrene when you will use. So that is known as your flame retardant polystyrene. You understand? So in market, you have different kind of polystyrene according to your need and your application. So this GPPC that is very commonly used in this market right now have a density is 1.04 to 1.09 gram per cc, and the transparency is up to 88% to 92%. See, the transparency is quite high, means this GPPS, sorry, is quite amorphous in nature. That's why the transparency is increased up to 92%. And the refractive index, okay, the refractive index is also quite high and made up of good gloss and for the decorative effect and good dimensional stability, GPPC. And HIPS, what is that? High impact polystyrene. It is very opaque and milky white bits or particles which can be any color, rigid, and very easy in processing. This HIPC, okay, they are generally made up of your stereotactic and isotactic material, okay. That is the reason they are quite hard, okay, and they have a very high strength as compared to your GPPS.
What is the full
And
form of
if you,
GPPS, please?
this
General
is
purpose.
Okay, sorry.
general purpose polystyrene,
Okay.
okay. And this
So
HIPS,
this
yeah, I can't hear you, Lalit.
yeah, sorry to interrupt. So this hips is like HI. One second. Now I am audible.
Yeah, you are audible.
Hello.
Yeah, you are audible.
Yeah, yeah. So I was asking. So this. Yeah. So I was asking this HIPS polystyrene is
Uh,
amorphous or semi-crystalline in nature.
Semi-crystalline. You can see they have a very, here, this property only tell us this is very semi-crystalline. Semi-crystalline might be it have 60 to 70% crystallinity. That's why they have a opaque nature. See, the concept behind amorphous and crystalline, okay, how much crystallinity is increased, that much you will receive less transparency and it moves towards opaque. Is that clear?
What makes it from GPPS to HIPS?
That is depend upon your synthesis process and what it make like what that GPPS to HIPS, it's depend upon whether they will form isotactic, seniotactic, or atactic.
No, some catalyst, yesterday you explained that some catalyst, if we add, it will change from this thing, the three category will come based on the catalyst what we are inducing into.
Yes, yeah.
So,
So in
particular
polystyrene, yeah, tell me.
which particular catalyst will help this GPPS to change as HIPS?
See, once you have GPPS, it is difficult to convert them into your HIPS, right? So whenever you do the synthesis, as I told you, this you have like bulk and suspension polymerization. So while you do this bulk and suspension polymerization, then only you have to set like which you want atactic mode, stereotactic, or isotactic. It depends upon as well as your catalyst as well as your suspension or bulk polymerization.
Okay, but then EPS is not GPPS, huh? That's
No, 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 no.
previous
EPS is different.
stage one, stage two,
See,
stage three you've shown. So in all these three stages will be available. This stage one, step one, step two, step three is applicable for both GPPS and HIPS, huh?
yes. See, this is, I told like how you can make this kind of box, okay, that we have molded foam, na? So this stage one, stage two, and stage three, you just have this kind of molded. So this is a transition from here to this.
Okay,
Okay.
step 3 is the final product.
Yeah, step three is your final product.
It's not a compounding thing, or it's not a poly
No,
process.
no.
Final
No.
product.
Yeah.
Okay.
Okay, so if we will go into the HIPS is very opaque as there is a increase in your crystallinity. Okay, and they have a very rigid as the crystallinity is increases, you can have a very rigid nature. Okay, and that is quite easy in processing because polystyrene are very soft in nature when you provide them the temperature and high strength. The impact strength of different rubber content is different. HIPS can be divided into two parts. Then further, this HIPS have two kind. One is your general, another one is your ultra high impact several levels. So this further division and all those things it depend upon this impact strength. You know, impact strength is very important. And what is impact strength means you heard about the scratch resistance. Okay, if you put a scratch to a material, they got a cut mark. Okay, so that depend upon your impact strength. If you have a very better impact strength, then they are very uh, good, you can say they are very good scratch resistance proof. Okay, so this polystyrene is always in struggle to have a better impact strength. That is the reason they do lot of modification to that. Then with decrease the improvement of impact strength, the tensile strength as well as your transparency is also like if you try to improve the impact strength, there might be decrease in your tensile strength and the transparency. So this always HIPS and the polystyrene material have a deal with to get a very proper strength as well as the transparency and the better impact strength. That is the reason HIPS, okay, means high impact polystyrene is mainly used in your packaging materials such as food, cosmetic, daily necessity, machinery, instrument, and your stationery packing, and can be molded using a variety of processing method. Okay, so these are the major application of your HIPS. In packaging, basically this HIPS is used. Then this is we have discussed about this HIPS. It can be used in your refrigerator, television, or the AC component or the water purifier, food service where these are the few things where this HIPS polystyrene is used. Okay. And this GPPC, okay, they are using mainly on the packaging, stationery, water purifier, and houseware uh, stationery things. EPS, they are mainly used in the food packaging, building construction, because in building construction also they use the polystyrene foam and in bulk molding. And this is extra polystyrene, okay? This is expanded and this is extra polystyrene. It has a very different application and that is in the green building and cold storage. See, this list can be more, okay? I just give you few, but if you go on like seeing in many industry, they develop this polystyrene as per their needs. Okay. So here this you can see this is your HIPS disposal cup. Okay. And this is your EPS polystyrene foam cup. Okay. How much the color and everything, even This we can made up of this HIPS coffee. Coffee, you drink na coffee. So the lid the upper use that is made up of your HIPS. Then HIPS tumbler cup and this food packaging. Okay, in food packaging industry, they are maximum cover with this expanded polystyrene because they will give you a very proper insulation property and they are quite light in weight as well as they are quite flexible in nature also. And this EPS polystyrene meat tray where they refrigerate it and EPS polystyrene, like XPS foam disposal plate, XPS foam disposal plate, they are quite foaming nature they have. And this, everyone in India, we use many of them in every kind of marriage or anything. So this polystyrene have a very huge application and it give you a very wide range of application. Okay. Next, there is but some limitation to that. Okay, polystyrene have certain limitation. What
Ma'am,
are that limit? Yes.
in last class we discussed about disposable and decomposable like that. Whether that also has a relation, which first one whether it cannot be disposed or decomposed. Is that any relation to those things?
You are saying the recyclability of polypropylene and polyethylene with polystyrene. Am
Ah,
I?
yes. That
Uh,
the previous slide you showed that no, expandable polystyrene, then high impact polystyrene and general purpose. Whether that is having a relation with the decomposability and
no, sir. No,
uh,
no, 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 no.
e-
The see, recyclability is different. Decompose is different. That you know, I think all you.
yes, the last
So,
one, yes, green building and color this thing, and it's a foam you told. So whether it is a decomposable item or
no, they use that is see the cold storage. Okay, and the green building. Green building means, if you know that they are building in concrete, they use this foam. Okay.
okay, ma'am. It will be mixed in the concrete itself.
Not, they will put that in between the two walls.
Okay,
Okay, they have a,
we used to add with cement. You are talking about those binders, huh? For leak proof binders, we used to add for ceilings and other. Is it related?
and this XPS means you can say that the extruded polystyrene foam.
Okay.
Okay, and have you heard about styrofoam?
No, no.
Styrofoam. Styrofoam is the trademark.
Oh,
Okay, and that is a brand name of this XPS, or
oh,
this is known as your extruded polystyrene foam.
Okay,
okay,
what about EPS expanded polystyrene, right?
This is expanded polystyrene. This is extruded level polystyrene. Okay.
Okay. For extruded level polystyrene, which application we are using?
That we use in the they are foam up. Have you ever saw in the packaging also we use they are quite big foam of polystyrene. Okay. They are easily take out. You can take out that also.
Are we
And
talking
in
about
the
bubble plastic?
yeah. Bubble
That
plastic means that is different. Uh, Whenever you receive any instrument or anything, you saw that they are packed in some kind of
okay.
styrofoam.
Okay, that white color, right? White color.
Yeah, white color. They are quite flexible. Means they are rigid also and flexible also. That is so different upon this packing. But you saw that they have this. protection from any kind of like your instrument safety point of view, they are keeping that. Okay.
Okay, so basically we are using as a dampening properties.
Yeah, it will absorb that, it will
Shock.
not affect any mechanical
That's what
damage to
it will
that
absorb the
particular.
vibration, any impact, shock kind of. So
Yeah,
you mentioned some trademark. What was that?
a styrofoam,
Styrofoam. Okay, okay,
maximum,
styrofoam.
yeah,
Okay, okay.
styrofoam is the trademark of your XPS.
Okay,
Okay.
okay, okay, got it.
In market, they will not say like XPS, they will say that this is a styrofoam. So that you have to understand this is your extruded grade polystyrene. Okay. And
Okay,
for
ma'am.
that, yeah, we have certain limitation to this polystyrene. Okay. That is the reason we do many of the copolymerization. What do you mean by the copolymerization? Means styrene will be there, but to uh, to just get out of this limitation, they use some other material so they can use that polystyrene for that particular application. So what are that? They have poor weathering property and very brittle. Okay. If you look into this last line, they are brittle in nature. Like when they are substance to your chemicals, okay, very poor chemical resistance. When very strong chemicals or the acid, suppose HCl, H4, these are very strong chemicals. When they fall upon your polystyrene, all the polystyrene will be dissolved there only. Okay. And especially to your organic, like many of your organic solvent, like acetone, isopropanol, alcohol, these are the chemicals. If that fall upon your polystyrene, then your all polystyrene will be melt. Okay. And flammability. Polystyrene is flammable and melt when it exposed to the flame. That is the reason you can find a grade that is known as your uh, flame flammability polystyrene or FPS. In the short form, they use that. Okay, so that polystyrene, they might include some kind of additives or the filler. Okay, flame retardant filler, so they can be easily flame. The flame retardant tendency is high on that case. Another property or another things that may disappoint when you give the application, if you expose this polystyrene for maximum time in your sunlight or any UV rays, okay, then you find out they are very yellow in nature. Okay, once you saw the color little bit yellowing is occurring there, then you have to know that that polystyrene is going to be degrade soon. Okay, as because they are very and then they will start to like separate, or it will be like broke into very small pieces also. So the outer application, it is difficult for the only polystyrene to do. Then next is your
This is
low
due,
heat. Yeah,
that
tell me.
yellowing, this due to the UV rays, right? UV.
Yeah, UV rays.
But
Because
yeah.
why that occur? Due to this present of this benzene group. Okay. This benzene group have a very huge impact on the coloring of your polystyrene.
Okay. But I think polystyrene is better compared to polypropylene in terms of UV protection.
Mm,
Any
yeah,
idea on this?
you can say that, but as compared to polystyrene, polypropylene are little bit more, and that also depend upon like if you add many additives are present. Okay, if you add that additives, then this problem will be solved. This is not a big
Okay,
problem,
I'm
and
talking
people
about
do.
without adding any additives or fillers. If I compare UV resistance of
Yes. Polystyrene is quite stable as compared to your polypropylene.
okay.
Yeah. And these have a low heat distortion temperature, means they can't sustain to temperature for a longer period of time as they will melt. Okay, they will melt and then they lose their property. And weathering properties also very less as they have a quite high TZ value, but still due to their structure, they have uh, poor weathering property and that lead them to the brittle. Okay, so these are the limitation to the polystyrene. So due to this limitation, they use some acrylobutadiene. Okay, so there they can have a very good uh, chemical resistance, or they can have a very good exposure, outdoor exposure, or the application. That is the reason polystyrene have a very copolymerization we do, means we added some different polymer or we added some different additives in order to achieve a very compactable and a wider application, because polystyrene is a very high impact strength also it's carry. Okay, so but we can't use them due to its own limitation. That is the reason we do the copolymerization with many of the polymers to get the wider application. Okay, so next vinyl polymer, we will study about your PVC, that is known as your polyvinyl chloride. Okay, I think you all heard about this polyvinyl chloride. And this polyvinyl chloride, if you see, this is your monomer. What is the monomer? Is your vinyl chloride. If you see, this chlorine is present over here, but adjacent to that, you have a double bond. So this also will go by your free radical polymerization. Okay, and this will also follow your suspension polymerization. Overall, in the industry, they use the suspension polymerization. In PVC, you might see that some have the very rigid PVC pipes. Okay, because polyvinyl chloride is maximum they are used for the application of pipes. Okay, so PVC is also a thermoplastic, that is often from your ethylene and the salt of vinyl chloride polymerization. This vinyl chloride, and with the help of ethylene, you got a vinyl chloride, and from vinyl chloride, we got the polyvinyl chloride. So in industry, they prominently or mass level, they use the suspension polymerization, account for over 80% of PVC produced. Whatever that PVC, okay, whatever that PVC produce in the market, they have a quite range of application, and they have a quite application in the field of pipes. This flexible pipes is often, see, this is flexible and this is rigid. Why that is? Actually, the PVC that we obtain, okay, they are quite rigid in nature. Okay, and by adding few plasticizer, the plasticizer are the low molecular weight compound that help that particular polymer to give a lubricating effect to that. That is the reason they make a very flexible in nature. So if you want to be get this flexible nature, or if you want to get this flexible PVC, then you have to uh, add the plasticizer. without plasticizer, you can't get your flexible PVC. But suppose the rigid PVC is what? The rigid PVC contain for about 55% of PVC that used in the market, they all are your rigid PVC. Uh, and while plasticide or flexible contain for the remainder means 55% is the rigid PVC, then your 45% are going to be of your flexible PVC. And
You
this
mentioned,
PV,
sorry to interrupt you. You mentioned some
yeah,
plasticizer we are adding. What was the name you mentioned?
plasticizer is a additives. Okay,
Yeah,
there
you
are
mentioned
diff
some name, something. Yeah, we are adding.
uh, sorry, I didn't mention any
Okay.
name of
So
any
for plastic,
pesticide.
I think you mentioned some PU form, something,
No,
or
I talking about the flexibility and rigid PVC only.
yeah, yeah. For flexibility, PVC for for flexibility, we are adding
Huh.
plasticizer, right? So any plasticizer example which we are adding.
See, the plasticizer that have lot of plasticizer, but for plasticizer for PVC, generally, like internal PVC, we use DOP. Okay, DOP is for because the plasticizing effect that we got by internal and external plasticizer. So that is DBP, DOP, that are different kind of plasticizer we have in the market. Dioctyl phthalate is a plasticizer. Okay, that basically we use in PVC. Okay, for making the uh, electric wire, we do the cable setting, right? So for that we use the DOP. It is a very colorless liquid if you see that, and that is soluble in water as well as. But DOP is a very commonly used in the market.
Ma'am, P stands for DOPP stands for
DOP, that is dioctyl phthalate, PHTHALATE.
Malate.
You can, yeah, you can Google it. That is name is dioctyl phthalate.
Okay, ma'am.
Yeah. And external PVC are also there. We can some of them can use the fatty acid also. Means the plasticizer that is you can get from the oil industry. They can use generally as your external plasticizer also. So that if I talk about this PVC, as this is also one vinyl polymer, you know, they are also going to be formed ectactic, seniotactic, and isotactic. So here, partially they have a seniotactic and but they does not have a very completely regular structure. Okay, but they are rigid because of this present of this chlorine. As the chlorine atomic number is quite high, then here the rigidity come into the play. Okay. But this vinyl chloride means this PVC have insoluble in your alcohol, water, or hydrocarbons. They are very insoluble. Okay, means if alcohol, water, or hydrocarbons, any solvent that fall upon these pipes, then it will not going to affect anything. But if you and acid and alkyl have very less effect. Okay, if I add some HCl, H2SO4, HF, nitric acid, these are very strong acid, or NaOH, KOH, these are the very basic alkyl. Oh, that can be affect little bit to it. Otherwise, it is quite stable for acid and alkyl also. But it this PVC is highly dissolved in ketones, chlorinated hydrocarbons, okay, chlorinated hydrocarbons, as well as if you do the mixture of acetone and carbon disulfide. These acetone plus carbon disulfide is the best solvent for dissolving of your PVC. Okay, but if you give the temperature to it, so you can see that the chloroform is a one solvent. Okay, that is your chlorinated hydrocarbons, chloroform or the DCM. So these are the solvent that can highly affect to your polyvinyl chloride. So what are
One
the,
question. Can you go to back slide, please?
yeah,
Uh, in that PVC we are using because this is chemical, basically chemical resistance compared to more
huh,
other plastic material, right?
oh, no, we can't say that.
Because generally we are using PVC pipes, right? Drainage pipes. So
Yes, yes.
that's what not water reactive kind of compared to that's what we are using for PVC, right? Is it right?
No, we have different grade of PVC pipes. Okay. Uh, and according to that grade, we have a PVC pipes applications. In my next two slides, I have a different types of PVC pipes and what they made and what for that pipe, what are the chemicals they are resistance. I have that. Okay.
Okay, that's what
Just
comparatively, I think PVC will be good because PP also different grade, right? PVC also different grade, but we are not using PP for a drainage pipe. We are using PVC particular grade because due to that chemical resistance, maybe.
yeah, that is the one of the reason.
Okay.
Okay. Yeah. So the PVC have lot of properties. First is the weathering stability. We will see PVC is resistance to aggressive environmental factor. It is
I'm only,
therefore the material.
no,
Yeah.
ma'am, one
Tell me.
doubt. This solvent we
Yeah.
are talking about, chlorinated hydrocarbon or acetone and disolvent or ketone. Actually, what is the
Uh,
purpose of this solvents with the PVC? Is there any application or is there anything that industry we do that use this solvent and PVC and do something? Last point.
okay. Yeah. I want to tell you in every whatever the polymer I'm going to teach you, every slides you have this common slide or this common topic. Like we have to know if I am dealing with this polymer, I have to know how much this polymer is chemical resistance and what are the chemicals that going to affect to this polymer. That is for my application point of view. Understand? Suppose if I make this PVC pipe is there, so I can use that for the alcohol transportation. So if I transported this alcohol in this PVC, then this alcohol is not going to harm this PVC.
Okay.
Is that clear?
Yeah.
So if we have to know, okay, this polymer is substance to what chemical, resistance to what chemical, or it is affected by which chemicals. Okay, that is a very grateful knowledge we should have because we are dealing with this kind of polymer. Okay.
But
And
uh,
I think thermal resistance also, right?
opposite of this,
Yeah, thermal resistance. Yes.
opposite to this, if PVC can get dissolved in this, which material will not dissolve these items? Or if I want to transport a ketone or this some
See,
what
acetone,
use
acetone you can keep in PP bottle, polypropylene. They are
poly?
quite safe. Yeah, we have
Okay.
discussed in the last slide also. Okay, for ketones, you can use Amrelites bottles also there, glass bottle, Amrelite glass bottles. Or you can use the PP. PP have different grades, so you can use the HDP. high density polyethylene bottles you can use for the ketones also.
Oh,
Okay?
Ma'am, one
Yeah.
request. Can you share that
Mm.
PPT, please? Because yesterday I was busy in meeting, so unable to attend. In fact,
Yes,
I
yeah.
requested I requested the coordinator also, DP coordinator also. We are
Uh-huh.
waiting for the previous lecture also, which we have still not received.
Actually, we
And
in
yeah,
one PPT we have make everything. Okay. So once this lecture will be over, then I can share with you. So that will be helpful for you to for also better understanding and
oh,
you know whatever I have like discussed here. So then you can read, then it will be
what
okay.
what about other lecture? Which other lecturer have given that also, or you will give which you have deliver?
Yeah, I will inform to them about this also.
Because those people also told that we will share, but still we have not received. Yeah.
Yeah, we will share. Actually, the lecture that particular person is taking have not completed yet. After my lecture, he is going to take that.
Okay,
Okay.
okay, okay.
Yeah, he have some work. That's why I'm taking in mid. Then
Got it,
he
got it.
will. Yeah. Okay. Yeah, and some people have told me the thermal properties also important. Yeah, thermal is very important. We can't send a product to the market until we give a data sheet of that particular thermal transition or the thermal transition temperature of that particular material. So,
oh,
weatherability is a very important parameter. Okay, as you can see, this is your very important property for or it's compared with polyethylene, polypropylene, or polystyrene. PVC is quite resistant to your environmental stresses. What is the environmental stresses? Means your like sun, your raining is there, or the temperature switching is there from minus to positive to then high temperature. So that is your environmental effect that the polymer is sustains. So PVC is quite sustainable to your environmental factor. That is the reason PVC is the first choice for every person to use them for your roofing. Okay, for roofing also they use PVC. And another thing is the versatility. PVC can be flexible and rigid. Both it can have that. So that is the reason we can use the rigid pipe as well as your flexible pipe. You know better how PVC can be flexible. Okay. Another thing is that fire protection. PVC is a material that resistance to ignition due to its chlorine content. Yes, the presence of chlorine, okay, uh, that help that PVC to sudden catch of the fire. Means if fire causes there, then this PVC can be little bit melt, but it will be not catch fire. Okay, longevity,
Means
it has a
means in which there is a chlorine content is there, the flammability retardant will be that less. It will not catch fire
yeah.
very easily.
Yeah, chlorine, phosphorus. Okay, that is the term, that is the relation with your chemistry of that particular element. Those who have vacant d orbital, df, these are the orbital that is fully of chemistry.
Okay, so you mean to say
We,
in chemical composition, if chlorine
hmm.
or phosphorus, anything is there, then it's a less flame retardant.
Yes, that no, I can say the less flame retardant as well as they can have a drop because they in the fire retardant have different stages. Okay, if suppose a polymer got catch fire for just 1 second, then it is there the ignition will be not happen, but they will fall into the drop bys. So that is a difference, that is the initial stage. Or some stage, certain there is a catch the fire. Okay, if you talk about like poly propylene, okay, there might be chances that they will sudden catch the fire, but that is not in case of your PVC. Then the longevity. Longevity means they have a very quite lifetime of that material. So PVC can be last up to 100 year, because if you saw that uh, you do the water system, water connection system in your housing, okay, you can see that they use that pipe for a very quiet duration of time. Even that they have a lot of environmental stresses is concentrated on that particular material, but still it have a very longevity. Okay, means the lifetime of that particular material is very longer period of time. Next is that energy recovery. Uh, Actually, PVC has high thermal power, means that is not that much, but initially they told that like PVC have a uh, energy recovery, means that is some of their intrinsic property. Then they have a very barrier property. What do you mean by the barrier property? Means it give you a insulation property. Okay, that's why PVC can make improvise to the liquid and vapor. Means because if you saw that the pipes of the PVC that can use for many transportation of your liquid. Okay, so that liquid, when that transport through this your pipes, then there might be chances that your liquid, suppose water is you are passing just normal the water in your piping system. If this barrier property is not there, then what will happen? The water can be vapor form and it will be gone to the vapor phase. Okay. But as it have a very perfect barrier property, okay, the liquid will stay in the liquid form inside your pipe. Then next is your recyclability. PVC is a recyclable more than your other plastic. Means it can be recyclable, okay, but only the mechanical recycling. See, the recycling have also many kind of recycling process: chemical recycling, mechanical recycling, hydrocrackings, different type of recycling process are there. So PVC is generally go for your mechanical recycling. They just crush them into and again they form. You can use this PVC. And economically efficiency. PVC is the cheapest of the large tonnage polymer, providing many they have a very cheapest. If you, PVC is quite cheap as compared to like many other polymers. And it have a very wide application. If you look into that, application of PVC is quite wider in terms of their rigid and flexible.
Ma'am,
Okay,
ma'am, energy recovery you told, no, that only please explain again.
energy recovery means what? That they have a insulation property. Okay, so can you see that the wire cables? Okay,
Yes, yes.
uh, the wire cables they that coated over there, that is a PVC, means they give you a very perfect insulation property, so that come under your energy recovery.
Okay, okay, ma'am.
Mm. So this rigid PVC and flexible PVC, in construction, window frames, that we have a window frames and very flexible in nature, so that is made up of your rigid PVC pipes, housings, siding, ports, and roofing. For that, you need your rigid PVC. Waterproof membrane, cable insulation, roof lining, greenhouses. For the preparation of greenhouses or the poly houses, they use this flexible PVC membrane. In domestic, like it have a lot of like drawer sites where you use this PVC and the laminated audio, and these are the domestic. But for the flexible, you use the flooring, okay? Shower curtains that many people have used, but right now people are not using that. Okay, they opt for different kind of layer of some polymer that give you the hydrophobic that they are using. For packaging, uh, does PVC have very less application, like transparent packs and blister packs also there. But for transport application, car seat back, okay, if you see that they are made from this rigid PVC, but flexible PVC like under seal, roof lining, leather cloths, okay, wiring insulation, there they use this flexible PVC. And you can see this is your cable thickening is also there here. In medical, that rigid PVC have not that much impact. But if you talk about your flexible PVC is quite high, that oxygen tank, okay, or bags and tubing for blood transfusion. If you see this blood packaging or this transfusion tabs, they all are made up of flexible PVC. Why? Because they have a very proper barrier application. Okay. Due to the proper barrier application, they can use as your for blood transfusion or the blood banks. Clothings, they have a very wide range also. Electrical, cable thickening, they have a very huge. And for rigid PVC, insulation pipes, jacketing, electricity distribution box, switches, okay, the switch that we use, that is also made from this rigid PVC. And plug housing and battery terminals also made of your rigid PVC. Right now, we will study little bit more in detail of the type of PVC pipes. Okay, what are the pipes and different grade of the pipes, and as for that, what are the application? So, if you talk about your unplasticized PVC, okay, means if you have unplasticized PVC, pipes do not contain any kind of plasticizer. You didn't add any kind of plasticizer. That kind of pipes you can use for pipes and fittings. Drinking water supply, you can use that kind of pipes. Waste, soil transportation, industrial application, and industrial drainage and sewage. These are the application for your unplasticized PVC. Okay, the name they term use like PVCU. Then chlorinated PVC. This chlorinated PVC is what? Uh, this chlorinated PVC is also known as CPVC pipe, where the content.
Hello.
Madam, your voice is not listening, ma'am.
You are
Have like a high amount of chlorine. So by the chlorination of
Ma'am,
PVC
what happened? I
resin
think we lost 1 minute
have very
discussion.
different
Can
application.
we, ma'am, can you
They
hear
are
us?
used for pipes and fittings,
Hello?
drinking water transportation,
Ma'am, can you hear us?
Hello, madam. I think your network issue, madam. Hello,
Ma'am,
hello,
we can't able to hear you. There is a lag is
hello,
there.
hello.
Still we can't able to hear you.
Yes, yes.
Hello?
Still.
Yeah, we can't able to hear you in between. Now is, can you able to hear us now?
Yeah, I can hear you.
Yeah,
You
now you can
can.
hear, but previously there was a lot of lag was there. So maybe you can start from chlorinated PVC, start from start. We lost in
Okay,
between,
okay.
we all, I think.
Okay. No problem. So the chlorinated PVC means what? We add more amount of chlorine into this. So why we are adding chlorinated? We are adding chlorinated to just give them more strengthening effect and more versatility. What is that? The okay, just give me 1 minute.
Uh, the other team members that I shared one WhatsApp group link. Please join that group in the chat box.
Okay, am I audible?
Yeah, you're
Excuse me.
audible. Yeah.
Okay. Yeah, so this chlorinated PVC means that here we add a specific chlorine and the high amount of chlorination, and that will maximum use in the industry for carrying the various range of temperature water. Means you can carry the 50 degrees Celsius water into through the pipe, 60 degree, the different range of temperature water, heated water, that you can carry through this chlorinated PVC. Next, we have molecular oriented PVC. So what this molecular oriented PVC is that here these pipes are among the different type of PVC that produced by turning the amorphous unplasticized PVC structure into more layer of to enhance the version of PVCU called PVCO. See, as I told you, this PVC also we receive atactic, seniotactic, and isotactic. So, what will happen? This rigid PVC have a atactic in nature, as we know that few of them have a seniotactic in nature. So, we try to convert this amorphous PVC into crystalline high. In short, we increase the crystallinity of PVC. Okay, the amorphous PVC, we try to increase the crystallinity among them, and that we call them as a molecular oriented PVC. And these they are used for pipes and fitting where high pressure is required. Okay, so the high pressure pipes that we use for mini cleaning purpose or like for many application that have high pressure pipes. So the high pressure pipes, they are manufactured, or the material that they have, that is known as your molecular oriented PVC. Okay.
That handling high pressure because due to that conversion from amorphous to crystalline, right?
Yeah, because the strength will be increased, right? The
Okay, okay.
crystallinity is increased and they are more oriented. So more oriented means the compactness will be increased. And that is the reason they can sustain to high pressure also. Okay. So here the barrier property will be increased.
So, ma'am, one question. So, when we talk about the unplasticized PVC, so
Hmm.
this is the same which is generally available in the market as PVC.
Yes.
Okay.
So high impact PVC, this is a very different kind of PVC. What we are doing over here is that
Ma'am,
this,
this
yeah,
PVC
yeah, I didn't hear you.
electrical and this thing, electrical and water pipes.
Yeah, electric. You are what you are asking?
First one, unplasticized PVC is a
Yeah.
market we are getting that electrical and water pipes. It is about that one, right?
Yes, yes, yes.
The
That
chlor-
commonly available. Yeah.
the chlorinated PVC is the hot water pipes which we are getting, which is in more of yellow color.
Yeah, yeah. Yes.
Okay, ma'am.
Yeah. And this high impact PVC, these pipes are the newest type of PVC pipes that are made by using different chemicals and inserting them to the unplasticized PVC, resulting in increase in the resistance to the impact. Actually, whatever this chlorinated, molecular oriented or high impact, we try to develop. As I told you, in the case of polystyrene also, how we change the as per our own application, as per our own needs, we try to modify or we try to bring some changes to that particular polymer to get our own application. For our need, we do the modification. Okay, so this in high impact PVC also, we try to modify this unplasticized PVC by adding many uh, we adding more chemicals into that to give a very high resistance to the impact. Impact means we want to increase the impact strength of PVC, means we want to increase the scratch resistance proof on that, where high pressure or extreme temperature is required, such as industrial liquid or commercial sewage system. So if you look into that industrial pipelines, they do suppose for their wastewater treatments or like for their heavy chemicals, especially in the dye industry or the pharmaceutical industry, they are using this, the wastewater treatment plant pipes, they are of high impact PVC because they are using lot of chemicals into that. So that can be react with the chlorine and that can the pipes can lose their property. Okay, that is the reason for where you have a lot of variation in the temperature of your any commercial liquid or any kind of sewage system you are planning for your wastewater treatment, then maximum they will choose this particular option for like high impact PVC. So we completed here polystyrene and PVC. Anyone have doubt about PVC?
Ma'am, this molecular oriented PVC, any
Yes.
example?
So this molecular oriented PVC, they have you saw that washing industry means where you use very high pressure,
Okay.
where high pressure is needed, and if you saw that pneumatic where the automated washing or automated anything is happening automated industry like in the food industry or the
Okay,
pharma
that
industry. Yeah.
pneumatic hose of blue color, which with some
Yes, yes,
and
small size, small diameter blue size pipes are there.
those are PVC, that is
uh,
molecular oriented.
Molecular oriented because they can sustain to very high pressure.
Yeah,
Okay.
okay.
That is the reason they need this molecular oriented PVC.
Okay.
Okay.
But for high pressure, I think we can use that what is a that nylon also, right?
Pardon me?
For high pressure application, we can use nylon also, right?
Yes, nylon. No, no. Nylon, you have a upper cover of nylon. Okay. There you can, PVC is also there and nylon is also there.
Okay.
And you can use nylon have thread, like you have a, uh, what can I say? You have a coverage to that.
Because nylon also having more strength.
Yeah, it have a strength. Nylon have more strength than the PVC.
Yeah.
Yeah. And this is again, you can see like it have a lot of applications. So I'm not going to this because already we have discussed the like application, but here we can discuss some limitation to that about like rigid PVC. The strength, they are very low in cost, but the stiffness is quite high, and the flame retardance also quite high, and better chemical resistance than your plasticized PVC. Plasticized PVC means your flexible PVC. Good electrical insulation and vapor barrier properties. Dimensional stability also quite good at room temperature, means they will not bend easily or they will not carry any kind of shape easily. That is the meaning of like good dimension stability. But they have certain limitation. What are that limitation? Difficult to melt process, means while doing the processing, the rigid PVC makes lot of uh, error into that, okay, due to very rigid in nature. And they are limited solvent stress cracking resistance, means like still it should be like high chemical resistance, and become brittle at 5 degrees Celsius. This is quite important for to add look into that. This 5 degrees Celsius, because PVC have TG less than your 6 degrees Celsius. So when PVC go to like below 5 degrees Celsius, so they are become brittle because they are below their glass transition temperature, where they can be act like a glassy state. Okay. Low continuous service temperature means the 50 degrees Celsius is the service temperature. Service temperature means, see, this rigid PVC has many application, but some disadvantages is that the service temperature is of 50 degrees. That is the reason we try to give them different kind of modification. So that unplasticized, like here, this unplasticized PVC have only for like your drainage, and there they can use. But when we increase like chlorinated, or the we orient the chemical structure of the PVC in a very well, then only we can go for high pressure, and the temperature range is very. So as that, this rigid PVC, if you are using the in the pure version, or the virgin rigid PVC, then last temperature you can work up to the 50. After that, you can get a smell of chlorine also, because chlorine is also liberate from afterwards that. In the flexible PVC have lot of advantages as compared to rigid PVC, but have some limitation to that. So what are that limitation? Here we can say that property can change with the time due to the plasticizer migration. This is a very important factor. The plasticizer we are choosing for PVC, we should check the migration limited. What happened? We add the plasticizer. The plasticizer will come above your PVC and they will give you the different property. That is the reason PVC in our research world, we do lot of study on the plasticizer, how not to migrate to the substance. It should be stay inside the material and give that effect. So this plasticization migration is a very big challenge. Okay. Attacked by the ketones, some grade swollen or attacked by the chlorine or the aromatic. If this few of the chemicals, when it fell upon the PVC, then you can see some of the blister kind of or some kind of bubbles that you can see. So we try to protect this flexible PVC from all those chemicals like aromatic hydrocarbons, ester, some aromatic ether, amines or nitro compounds. Okay. Then next is what? Okay. So next is what that not suitable for the food contact with the some. This flexible PVC is not allowed in the food industry, okay, because we are adding the plasticizer. So that plasticizer, when it's come into the surface of PVC, might be it can come contact with the food, or it can contaminate the food. That is the reason flexible PVC is quietly avoided in the food industry. And as compared to this rigid PVC, this flexible PVC have lower chemical resistance. As in the my previous slide, we are discussing it have a application in the construction. So this window slide, if you're seeing that, this window panel, side of this window panels, they are made of your PVC. And you have seen this domestic pipe in packaging also this PVC is happening and wire and cables so that we are seeing in the everyday. And we can make this flexible kind of toys, okay? And in the blood fusion or the blood packing bag that also used in the medical and this in the automotive industry that has a huge application. And this is in the clothing clothing, they are using this strip of PVC. As you know, PVC have flame retardant property, so they are using in this clothing industry of this firefighter or some of the fire safety officers also wearing this kind of cloths. Okay.
You mentioned that low continuous service temperature of 50 degrees Celsius. Can
Hmm.
you little bit again explain that, please?
Means if you are using the virgin rigid PVC or that is known as your unplasticized PVC, okay, whatever work, suppose you are doing the processing in of that, okay, whatever you, if you are doing extruder or whatever processing you are doing, so you can't go beyond 50 degrees Celsius. If you'll go beyond 50 degrees Celsius, then your PVC will be degrade.
You mean to say, let's suppose in injection molding, we are using
Hmm.
PVC,
Hmm.
then temperature should be less than 50 degrees Celsius.
Yeah, I'm talking about virgin rigid PVC. No
Okay,
additives.
I got it. Virgin rigid PPT. You're talking about rigid.
Yes, yes.
So then we can say the pipe, that rigid pipe, which is manufactured through extruder, right? That is
Hmm.
below 50
Hmm.
degrees Celsius only.
No, they are using heat stabilizer there.
Okay, by heat stabilizer, rigid PVC, we can go more temperature.
Yes, yes, because that particular compound, that particular additives, okay, it like sealed this PVC. Okay, that heat effect is only received by your heat stabilizer. It will be neutralize the temperature.
Ma'am, we are actually PVC is not done in injection molding process. No, this is an separate process. No, products are coming in some other process. No, it's not in injection molding.
Yeah, and PVC is that peculiar behavior material. For that, you need have a specific extruder. You need a specific, if you are using two roll mill also. Okay, you need very specific because PVC temperature variation is quite obvious, and the release of chlorine is also harmful for the health. Okay, give you a lot of hazardous health hazardous. That is
Then
the reason PVC processing need very specific guidelines.
you mentioned we are using for seat bolster, sorry, seat upholstery cover kind of, right?
Uh, in where?
In automotive, if you see that
Yeah, yeah,
automotive
yeah.
image, right?
Yes, yes.
The seat cover that is a PVC only, PVC layer.
Yeah.
Then
That I
temperature,
do by
their
compression
temperature will be
molding.
more because at hot area the temperature can be 60 degree also. But
Yes.
then you mentioned that it's a low continuous service temperature. Then how?
See, whatever polymer we are using, it's very difficult to we use them in the virgin form, first of all. If you are designing anything from polymer, you have to add the additives.
Okay,
Every polymer have their limitations according to their structure. So for that seat cover or that for the automobile, they are using lot of, see, if you see actual PVC, they will look like in a transparent, okay,
okay,
and white is in color. But whatever you are getting in market, they will be in different color because they every PVC they do the master batch. So you can't say like I'm using virgin rigid PVC. They are going adding anything to that as for their application. Okay, if they are doing manufacturing, the PVC they are manufacturing for your automobile industry, definitely they will use antioxidant to that. They will use plastics, they will use heat stabilizer to that. Then they will use cross-linker to that. There are a lot of additives they use before they are going to do the process. And PVC, it's very difficult to do the processing.
okay.
Yeah, that is the reason they add lot of additives into the PVC.
So
Okay, but the
what?
PVC pipes that we are using for home, for the drinking water, that is, they are using the additives quantity and everything will be quite low. Okay, and they are not that much effective, or that they are not going to involve in that water or it get contaminate the water.
Okay.
So these are the few criteria also you need to take care before you are using for that.
So in injection molding, we are not using PVC, right?
Yeah,
And
we
that pipe,
basically do, we
yeah,
do the compression molding also for PVC.
okay, that pipe, rigid pipe, we are using compression molding.
No, no. Pipe we do manufacture by extruder.
Extruded, okay.
Yeah. All pipes are continuous process, no? Pipes making are.
Yeah.
Yeah.
Ma'am, I
Uh,
have one doubt.
yeah.
In PVC, we are doing fitting also, na? In injection molding.
Yes.
Oh,
Dekho, for pipes, for the manufacturing of pipes, we are using extruder. Okay.
yes.
But there are different kind of product that we are manufacturing. suppose for the medical equipments and all those things, we are using injection molding. What I am saying is that for PVC processing, you need different kind of setup. Suppose if you are using injection molding also, the injection molding is only particularly preparation for your PVC material. Is that clear? Suppose if I have an injection molding, there I can be molded my PP material, okay, or I can molded my like PE material. In that injection molding, I can do the molding, okay. But for PVC, we can't do that multiple versatility polymer. We can't use that. We only can use PVC material. So the for PVC, whoever will design the injection molding or extruder or two roll mill or compression molding, they have very different specification to that. I'm saying that. Otherwise, you can molded PVC in injection molding also, extruded also, compression molding also, two roll mill also. But the thing is that according to their property or according to their application, the specification should be vary. Is that clear?
Yes, ma'am. I heard about some specific word using in their extrusion and injection molding. They
Yes.
are classified with the K value. Some of them called K value for that PVC.
Okay. That is the K value you will study when you will study about the properties of polymer. Okay.
Okay.
Yeah. Uh, so we can continue for the next polymer or in this class or in the next class. Is
We
it
can,
okay?
no problem. We can continue, ma'am.
Tomorrow, which topic we are going to cover?
Tomorrow we will cover polyvinyl alcohol, polyvinyl acetate, polymethamethyacrylate.
Okay.
So like important polymer that see in my very previous slide also I saw like many of the vinyl polymer are there. Okay, but the important vinyl polymer that is a huge demand in this market and that is currently we are using. I'm going to cover that many of vinyl polymer. Okay.
Okay.
Yeah.
And
So
one question that seat cover,
yes,
that how we are making that cover. Basically, we are telling resin also, that same thing, na? Same term.
you are talking about this kind of seat
Yeah,
cover.
yeah, yeah.
This is made up of your here see, the textile we are using that is of your nylon or nylon is there.
Basically, it's a kind of a thread, and above thread there is a layer of PVC,
Yes,
and which we are
that
telling
they
resin also, approx 1
yeah
mm thickness.
yeah.
So how we are making that basically fabric kind of resin?
Sorry, I don't know about how they do the fabrication process here. I think they
Not
are
fabrication. Basically, this is a cloth, kind of a cloth. We can say cloth also, or some
yeah
particular GSM kind of.
yeah, and I think they are making from like composite kind of things. Composite means polymer is there, but you have use this PVC if they use that as a resin over there, so then that kind of layer can form.
But how will be the manufacturing process? Like
Sorry, I don't know
mm,
about the manufacturing process.
maybe. Okay.
Yeah,
Yeah. Thank you.
okay. Yes. So thank you so much for today lectures. Tomorrow,
Ma'am,
yeah,
just one one question, sorry.
yeah,
You told us that the impact strength we can refer to the resistant to scratch, right?
yeah.
So I have one question. Like in metals, the resistance to scratch is generally referred as hardness, and impact strength is like ability to resist any force or any load. So
Yes.
in case of plastics, it is like different or it is the same?
Yeah, it is different.
Okay. So
See,
impact strength is basic. Yeah, please go on.
yeah, that is in case of metal have their crystal structure is quite perfect fitted in their lattices. So the concept of impact strength in the metal is quite different than your polymer because polymer is a very different material. As this polymer have a viscoelastic material and your metal is of elastic material. Elastic deformation is there, plastic deformation is there. But in case of your polymer, you generally didn't find any elastic deformation. Here we do only the plastic deformation. So the many of the property from your metal is vary from your polymer. Okay. And the
Okay.
impact strength test is also done in that way. For metal, they do very different way. Okay.
Okay.
Uh, so we will start tomorrow and I'll join early and we will complete the vinyl polymer person tomorrow. Okay? Yeah.
Okay, ma'am.
Yeah. Thank you so much.
Thank you.